Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. For exam P on probability, let x and y be identically distributed independent random variables such that the moment-generating function of x plus y is m sub x plus y of t equal to 0.09 e to the minus 2t plus 0.24 e to the minus t plus 0.34 plus 0.24 e to the t plus 0.09 e to the 2t for t between minus infinity and plus infinity. Calculate the probability that x is less than or equal to 0. Well, let's look at the solution. These two random variables x and y are independent, and the moment-generating function of a sum of two independent random variables is a product of the moment-generating functions. But we are also told that x and y have the same distribution and the same moment-generating functions, so that mx plus y of t is equal to mx of t squared. This means that we can find mx of t by expressing mx plus y of t as a square of an expression which can be identified as an MGF of a probability distribution. MGF standing for a moment-generating function. So we work carefully on writing mx plus t of y as a square of another expression. So mx plus y of t is 0.09 e to the minus 2t, and you can see that that's a square of 0.3 e to the minus t. And then 0.24 e to the minus t plus 0.34 plus 0.24 e to the t plus 0.09 e to the 2t, and that's a square of 0.3 e to the t. Okay, so we write the two squares that we see immediately, that we have there. 0.3 e to the t squared plus 0.3 e to the minus t squared. And then if we have any kind of a square of a sum, then it will have double products of the things that are in the sum. Well, we can write out here 2 times 0.3 e to the t times 0.3 e to the minus t, the two things that are squared, and minus the same thing, plus and minus, so that it's really 0, but we observe kind of that it's there. But 2 times e to the minus 2 times 0.3 e to the t times 0.3 e to the minus t, that's the power, the exponentials cancel out, and this is simply 0.18. And then these two expressions that we wrote, they add up to 0. I just create them so that we can have that double product and see what happens. Plus 0.24 e to the t plus 0.34 plus 0.24 e to the t. That's from the original expression. Okay, so we have 0.3 e to the t squared plus 2 times 0.3 e to the t times 0.3 e to the minus t plus 0.3 e to the minus t squared. And then negative 0.18 plus 0.34 is 0.16, which happens to be the square of 0.4. And then plus 0.24 e to the minus t plus 0.24 e to the t. Okay, and then we have those two squares plus the square of 0.4 plus double product of 0.3 e to the t and 0.3 e to the minus t plus double product of 0.3 e to the minus t and 0.4 plus double product of 0.3 e to the t times 0.4. So we have three squares and then double products of everything that's in them. Well, that's equal to 0.3 e to the t plus 0.4 plus 0.3 e to the minus t squared. So we just wrote the moment-generating function of the sum as a square of something. But because we know that it's a square of moment-generating function of x, then this expression that we just found has to be m sub x of t. So m sub x of t is equal to 0.3 e to the t plus 0.4 plus 0.3 e to the minus t. And then we write it as 0.3 e to the 1 times t plus 0.4 e to the 0 times t plus 0.3 times e to the minus 1 times t. And now you should recall what you learned about the moment-generating function of a discrete random variable. Well, it's probability times e to the value of the random variable times t for all points that have positive probability. So in this case, this means that x is equal to 1 with probability 0.3. That comes from 0.3 e to the 1 times t. And 1 is the thing that's multiplied by t, and 0.3 is the probability of it. Then 0 with probability 0.4, where 0.4 comes from the coefficient 0.4 in front of e to the 0 times t, and 0 is the value of the random variable. That happens with probability 0.4, plus 0.3 times e to the minus 1 times t, and negative 1 is the value of the random variable, and 0.3 is its probability. And what we see is that it makes perfect sense. This MGF that we have is the MGF of that x. X is a perfectly legitimate random variable with that MGF. The probabilities add up to 1. Everything works nicely. And what is the probability that that x is less than or equal to 0? Well, it's simply the probability that it's negative 1 plus probability that it's 0. So it's 0.4 plus 0.3, so it's 0.7. That's answer E, and we're done with the problem. You could actually just get it done from what you see. The MGF of x plus y is because based on it, x plus y has to be negative 2 with probability 0.09, negative 1 with probability 0.24, 0 with probability 0.34, 1 with probability 0.24, and 2 with probability 0.09. And we know, in fact, that x and y have identical distribution, and that the only integers that, when added to themselves, produce values on the above lists are 0 plus 0 is 0, negative 1 plus negative 1 is negative 2, 1 plus 1 is 2. So the most reasonable candidates for the values of x and y are negative 1 and 0 and 1. And then we note that negative 2 is negative 1 plus negative 1. Negative 1 is negative 1 plus 0, or 0 plus negative 1. 0 is equal to 0 plus 0, but also negative 1 plus 1, or 1 plus negative 1. And 1 is 1 plus 0, 0 plus 1, and finally 2 is equal to 1 plus 1. So x, which has the same probability distribution of y, has to be 1 with probability 0.3, because 0.3 times 0.3 is 0.09. 0 with probability 0.4, because 0.4 times 0.4 plus 0.3 times 0.3 plus 0.3 times 0.3 is 0.34. Negative 1 with probability 0.3, because 0.3 times 0.3 is 0.09. Note in this that negative 1 is negative 1 plus 0, 0 plus negative 1. It's also confirmed with 0.3 times 0.4 plus 0.4 times 0.3 is 0.24, just as 1 is equal to 1 plus 0, or 0 plus 1, is confirmed with 0.3 times 0.4 plus 0.4 times 0.3 equal to 0.24. And then, of course, we get the answer. Probability that x is less than or equal to 0 is probability of negative 1 plus probability of 0, which is 0.4 plus 0.3, so 0.7. So this second method of solution is a bit of a guess, but the guess is verified by calculation. And you might wonder how you can guess this. Well, the key is realizing that what integers added to themselves give you values of x plus y, and then following up on that to verify that everything works. And it's answer E again. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. It was previously published as an online exercise that I posted in a PDF file, but now it became a video. Good luck in your studies and good luck on the test.